When it comes to sketching our cubic graphs in factored form, we treat them much the same way as we do our parabolas. So we find our x-intercepts by letting y equal to 0, find our y-intercepts by letting x equal to 0, and then we find that our cubic has a more general shape. When we're looking at our factored form of our cubic, it tends to look a little bit more like that. So specifically point of inflection like that. So when our graph is in a factored form, or when it's not just y equals x cubed, our graph tends to, it comes up to a maximum, comes back down again to a minimum value, and then comes back up again. So that's my general positive cubic function, all right? So the process to sketch them is to find all of our x and y intercepts and then join the dots, really. So if we look at the first one here, so the x-intercepts occur when y is equal to 0. So if I put y equal to 0, I get 0 is equal to x minus 1, x plus 2, x plus 1. So that's in factored form already. So that means that each of those terms individually could possibly equal to 0. And that's why we use our null factor law. So I get x is equal to 1, x equals negative 2, x equals negative 1. So my factors, sorry, my intercepts, negative 1, 0, 1, 0, and negative 2, 0. So we might just work with negative 2, negative 1, positive 1. Yeah. Y-intercept, we put x equal to 0. Y-intercept, if I put x equal to 0, I get y is equal to 0 minus 1 times 0 plus 2 times 0 plus 1, which equals negative 2, which I'm going to call there. So it's a positive cubic graph, so it looks a little bit like that. So in terms of sketching it up, let's get a different pen. I know that my graph goes through, it's got to start from the bottom left and go up. It goes down. Now, where does this turning point occur? We don't really know. It could be to the left, it could be to the right. We just know that there's a turning point, all right? And is it below it? Well, it's going to be below it or on it. So for the sake of not keeping things perfectly symmetrical, I'm going to go through it, down, and then come up. Okay? So the important things to note are, I guess for us in particular, where those points are, we don't know. Okay? If you'd have drawn it, and it could be, in fact, if I get the actual graph, which we can see up here on the top left, the turning point is in fact on the right-hand side. Okay, so, and that was just really a guess more than anything. What isn't negotiable is these values here, negative 2, negative 1, and 1. Okay, so that's my basic shape. And I guess we have three distinct intercepts, and so we have three distinct factors, so three distinct intercepts. Okay, let's come to the graph B now. I'll just get rid of some of this scribble. So we notice this one here, we don't have three distinct factors. In fact, we've got a quadratic factor there. We've got one that's doubling. So that gives that intercept a particular feature. So again, let's find our y-intercept. Y-intercepts, put x equal to 0. And we get y is equal to negative 0 squared times negative 1, which is just 0. So 0, 0 is going to be one intercept. And if I solve each of these and find my x-intercepts, if I solve each of these factors equal to 0, I'm going to get x is equal to 0 and x is equal to 1. Now, because this factor is squared, I think it's, well, actually, first things first, negative sign out the front means it's a negative cubic, so it's going to come down that way. All right, so start from the top left and make our way down to the bottom right. because, and it's getting hard to see it all, because this x squared term is in fact a squared, that particular intercept acts as a squared intercept, which means it acts as a turning point. So what I do know is my graph comes down through the intercept. Now, because it's a squared term, it's not an intercept, it's a turning point. So it goes back up. And then I know it's got to come down through the other one at x equal to 1. All right. So a couple of things. I know that that's 0, 0. I know that that's 1, 0. All right. And I know that the 0, 0 is a turning point simply because of the squared nature of that particular factor. All right. Now we go to C. If we have a look at C, we can see that it's not in factored form. And so, in short, we need to put it in factored form. So how do we factorize a cubic? We do our division, polynomial division. All right. So I'll do, so the first step is we have to find ourselves a factor of that function there. That will, so I can divide by that factor. To find the factor, I want to find a value that I can substitute in to get 0. So if I look at the coefficients here, I've got a 1, a 5, 2, and a 6. 1 plus 6 is 7, 2 plus 5 is 7. I'm confident 1 or negative 1 will give me a 0. So I'm going to go with a negative 1 initially. P of minus 1 is equal to negative 1 cubed plus 2 times negative 1 squared, 5 times negative 1 minus 6. Negative 1 cubed is minus 1 plus 2 plus 5 minus 1, minus 6, which is equal to 0. So P of negative 1 is a solution. So x plus 1 is a factor. X cubed plus 2x squared minus 5x minus 6. Let's do our polynomial division. What do I multiply by? X squared. X squared times x is x cubed. X squared times 1 is x squared. Subtract them off. 2x minus x is x squared. Bring the 5 down. So it gives me a plus x there. Plus x times x is x squared. Plus x times 1 is x. Subtract them. Minus 6x. Bring negative 6 down. Minus 6 at the end. Minus 6x minus 6 gives me 0. And if I've done it correct, I should get 0. All right. What I want to do now is I'll come over here. So that means I've got x plus 1. Well, what's my solution? Is x squared plus x minus 6 times x plus 1. So I've got one linear factor. Now I need to factorize that blue term, that quadratic. So if I do plus 3 minus 2, there's my 3 linear factors. So now my function is factorized. So now I can see quite clearly x-intercept, if I put y equal to 0, I want to solve that expression equal to 0. So therefore I'm going to get x equals negative 3, positive 2, and negative 1. So I get negative 3, 0, positive 2, 0, negative 1, 0 as my x-intercepts. All right. So if I mark those on my graph, I'm going to have to go in 2, so call that 2, 4, negative 2, negative 4. So negative 3 is here. Positive negative 1 is here. Positive 1 is there. Note they're all 3 linear factors. So none of them are squared, so none of them are turning points. Let's go to y-intercept. Y-intercept, if I put x equal to 0, back to the original equation, 0, 0, 0, negative 6 at the end, that's my constant. So -6, it's going to be slightly off the charts, isn't it? Is it a positive or negative? It's a positive cubic. So my graph is going to go up through -4. At some point in time, it'll turn down. Positive through -1. Turning point, again, is it before or after? I'm going to say it's after. And then we can come back up through. All right. So we should label -3, 0, -1, 0, 1, 0, and we said 0, -6. All right. Don't forget, when we had to do our polynomial division, it is possible x plus 1 was a factor, -1 out the front. Coefficients, 1, 2, -5, -6. We can do that synthetic division. Bring the 1 down, -1, add the 1, -1, add them, -6, +6, 0, x squared plus x minus 6. Yeah, so it's in these situations I think the synthetic division is really nice and short and sharp and quick. All right. So there's, I guess, the basic approach to sketch our cubic graphs. We must factorize them. Okay, if they're not factorized, we have to factorize them. If they're 3 distinct factors, we've got 3 distinct intercepts. If one of the factors happens to be repeated, and we'll do a little bit more on that, it's a turning point. Yeah, negative out the front, it's a different direction. All right, so let's have a look at a few more. So again, we've got a linear. So what do we know? We've got a factor at +1. It's a negative graph, so it's going to go like that. X squared plus 4x plus 5, we will try to factorize that. But if we do a quick check of the discriminant there, b squared minus 4ac, which is 16 minus 4 times 1 times 5, I get -4. Therefore, I get no solutions. All right, so there's no other factors. So let's get a y-intercept. Y-intercept, if I put x equal to 0, I get y equal to negative of -1 outside of 0 plus 0 plus 5. So it's equal to +5, so I get the point 0.05. So what if we call that? That's 4, I don't know, we'll call that 5. So what do I know? All I know is it's a negative cubic. That's an intercept that's going up through there. Where the other turning point is, we're not sure. Okay, I must confess I know it's a little bit like that because I looked it up on a CAS, and you would need to do the same thing. Okay, so all we do know is that there's an intercept here. Now, is that a turning point? I probably shouldn't have drawn that as a turning point. Okay, but I know there's an intercept there. So an alternative graph that would have been reasonable would have been something like that. As long as that point there is 5 and that point there is 1, they're reasonable. Without a case to explore further, they're reasonable graphs to do. So in reality, for something like D, we would give you a CAS. You would have access to your technology to find the key points. All right. All right. E and F both look similar in that we have repeated factors. And so we spoke about repeated factors. Repeated factor means that intercept is now a turning point. So we know that at x equal to 0, y will equal 0 times 0, which is 0. So 0, 0 is 1 point. Okay. So if it's factored already, so we know that x is equal to 0 or x minus 1 is equal to 0. So we get 0 and 1. So I'm going to make that 1, that 0. 1 is a turning point. It's a positive cubic. So my graph goes up through my intercept. is going to come down to go through at 1. Because 1 is squared, x minus 1 squared, we know it's a turning point there, so it looks something like that. So we've got the point 0, 0, 1, 0. We've got all our key points labelled. We don't know, the only turning point we know is the point 1, 0, because that's a repeated linear factor. Right? Again, we can see a repeated factor again here, a 2 minus x here. So if you like, that's a negative out the front of x minus 2, 2x plus 1 all squared. So let's go through the process. Let's put y equal to 0. I get 2 minus x is equal to 0, or 2x plus 1 squared is equal to 0. From in here, I get 2 is equal to x. Yeah, if I put x equal to 2 there, I'll get 0. Here implies 2x plus 1 is equal to 0, so x is equal to minus a half. So they're my intercepts, and in fact at negative half, we get a turning point because 2x plus 1 is squared. So I'm going to make, I'll have to make that a half then. That's 1, negative 2, 1, 2, minus a half might be there. Positive 2 is over here. We need a y-intercept. If I put x equal to 0, I get 2 minus 0 times 0 plus 1 all squared. 2 times 1 is 2. So we'll make that point there. We said it was a negative cubic, didn't we? Because it's a minus x in here. Okay, if I expand that whole expression, I'm going to end up with a negative x cubed. So where did we say our turning point was? That was a turning point, wasn't it? So it's going to come down to negative a half, where we said it was a turning point, go up through, and then come, oh, hang on, come down through 2, isn't it? It is. So maybe I'll just sort of put that a bit sharp and come down through 2. So we've got negative a half 0, 2, 0, and the point 0, 2, was it? 0, 2. Okay. Off you go.